Hello and welcome to helpyourmath.com. In this video, we're going to look at the graphs of transformed sine and cosine functions with vertical and or horizontal transformations. Because we're looking at a whole lot, I assume that you've already watched the video that did not include vertical and horizontal transformations, so I am going to make some assumptions. If you need to rewatch that, you should be able to find it on the right-hand side of your screen. You might want to rewatch that if you need some additional support. Okay, so normally here, when this is a cosine graph, so normally if we had the parent function, we would have f of x is equal to cosine of x. For a transformed function, it might be written of the form a times cosine of bx minus c plus d. And so a is the amplitude, as we saw previously, and b is going to help us determine the period. Help with period. And then what C and D are going to do is they're going to cause shifts in the graph. So C is going to move the graph left or right, and D is going to move the graph up or down. Just like with standard functions, that's what happens. So this is going to move the graph horizontally, and D will move the graph vertically. Okay, so we need to keep that into consideration as we look at these four examples. Well, specifically this one with the cosine graph. Okay, so first thing we're going to do, we're going to determine the amplitude. The amplitude is found by taking the absolute value of A, which would end up being 2. The period is found by dividing 2 pi by B, so this would be 2 pi divided by 3. Now we want to fill in the 5 key points for one period. We want to keep in mind, so the good news is we want to be careful here with this -1. It might be ambiguous to you, but it shouldn't be. Because it's not in parentheses, the -1 is a vertical transformation. If the -1 was to be included as part of the cosine function itself, it would have to be inside parentheses. So for clarification purposes, I can put parentheses there, and I'm not changing the original function. This is how it was intended to be written. So this indicates that there is a vertical transformation. And this also means that we're going to take the graph and we're going to move it down 1 unit. So a normal cosine graph, the parent function would normally start at 0, 1, but this one would, if it was the parent function, it would start at 0, 0, and that would be the maximum height of the cosine graph. But this one, let's see, is it going to start at 0, 0? It is not, because the amplitude was not 1. So this one will actually start at 0, and then it would be -2 based on the amplitude, but then it's getting shifted down even 1 more unit, so it's actually going to be at -3. So the very first point will be at 0, -3. From there, and what we can do is we can use that vertical transformation. So if we said y equals -1, that would be like the middle line of the graph. So we could draw this in. It's not an asymptote, it's just to help us figure out. This would be the midline for this graph. So every other point should hit that midline. Every other point should be at -1, but we're already starting 2 units below that because of the amplitude. The fact that it's negative means we're starting below, and then the fact that it's 2 means we're starting 2 units below the middle. Next, we're just going to fill out the x's, and then we'll fill out the f of x's or the y's after. So to figure out the rest of the increments, what we do is we take the period and we divide it by 4. So this would be 2 pi over 3 divided by 4. This would end up being 2 pi over 12 or pi over 6. So we're going to just keep adding pi over 6's to our x's. So 0 plus pi over 6 is pi over 6. Pi over 6 plus pi over 6 is 2 pi over 6 or pi over 3. Pi over 6 plus pi over 3, that would be pi over 2, because that would be 3 pi over 6, which would simplify to pi over 2. And then pi over 2 plus pi over 6 will be 2 pi over 3. If you're not sure, you would need to create a common denominator here, right? If we're going to add these, common denominator, the best one to use would be 6, sorry, I'm multiplying by 3. That would be 3 pi plus 1 pi is 4 pi over that common denominator 6, which simplifies to 2 pi over 3. And because there was no horizontal transformation, these should match. In examples where there is a horizontal transformation, they will no longer match. Okay, so now filling in the y values. So remember what's happening here. We're starting at the minimum because the fact that the A is negative. And we're starting 2 units below the middle line, where the middle line is at -1. Now we go back to the middle line, so we're going to go to -1. We're going to go up to the top, which will be 2 units bigger than -1, which is 1. Go back to the middle line and back to the bottom where we started. All right, we're going to graph 2 full periods, and we all know I like to skip, so we're going to do this one here is pi over 6. This one here is pi over 3, pi over 2, and 2 pi over 3. It's probably easier to go into the negatives because then you don't really have to come up with new values here. You can just use the ones that are given and stick negatives on them. Negative pi over 2 and negative 2 pi over 3. All right, and so what's happening here? We're starting down at -3, up to the midline, up to the peak, the maximum, back to the midline, back to -3. So there's 0, -3, which is right here. Now we're going to do pi over 6, -1, pi over 3, 1, pi over 2, -1, 2 pi over 3, back to -3. A nice smooth curve for our transformed graph. In the next example, we have 2 times sine of x over 3 plus 4. Again, that plus 4 is indicating that there is a vertical shift of 4 units. So this is vertical 4 units up. So normally a sine graph would start at 0, 0, but this would start at 0, 4. This also indicates to us that the midline is moving to y equals 4, so we can go ahead and draw that in 1, 2, 3, 4. Okay, so this is our midline. Every other point should hit that midline. The amplitude is the absolute value of a, which is 2. The period will be 2 pi divided by b. That's 2 pi divided by 1 over 3, which is 6 pi. And we'll start by completing the x's, and then we'll fill in the y's from there. So to figure out the key points, well, we know we're starting at 0 since there's no horizontal transformation. Then to figure out the rest of the key points, we take the period and divide it by 4. So we're going to take 6 pi and divide it by 4, which will be 3 pi over 2. So we're going to add 3 pi over 2's each time. So this will be 0 plus 3 pi over 2. 3 pi over 2 plus 3 pi over 2 would be 6 pi over 2, which is 3 pi. Then 3 pi plus 3 pi over 2 will be 9 pi over 2. And 9 pi over 2 plus 3 pi over 2 would be 12 pi over 2, which is 6 pi. And we do get to do the check since there was no horizontal transformation. To figure out the x values, so normally the graph, as I mentioned, this is a sine graph, so it should start at 0, 0, but we're taking that midline and we're shifting it up 4 units, so it's going to start at 0, 4. Since a is positive, we know that we're going to start at the middle, go up to the top, back to the middle, bottom, middle. So we're going to go up and we're increasing by 2 units because of the amplitude being 2. So it's going to go up to 6, back to 4, down to the minimum at 2, back to 4. So every other point should be that midline point. All right, so we have, let's label our graph. 3 pi over 2, 3 pi, 9 pi over 2, 6 pi. And again, just to make it easier on yourself, just do the negatives of these rather than coming up with the next ones, because it'd be annoying if you made a mistake labeling your x-axis. Negative 9 pi over 2 and negative 6 pi. Okay, so negative 6 pi is starting at 4. Negative 9 pi over 2 is going up to 6. We go back to the middle, down 2 units from the middle, back to the middle. Now we're starting at 0, 4. We go up 2 units, back to the middle, down 2 units, back to the middle, and we connect these with a nice smooth curve. And there will be 2 periods of this particular sine curve. I imagine these next 2 examples are going to have these horizontal transformations. Oh dear, here's the first one. All right, so the amplitude is going to be the absolute value of a half, which is a half. The period is going to be, sorry, I was trying to write period, and then I was like, why am I doing that? 2 pi divided by b. That'll be 2 pi divided by 2. So the period is going to be pi units long. So from start to finish, that should be a change of pi units. The 5 key points, so we can figure out the increments. This is going to be a little bit tricky because we do have a shift here. The increments are going to be the period divided by 4. That would be pi divided by 4. So we're going to go in increments of pi over 4s. However, we do have this shift. This is shifting to the right pi over 6 units. So normally we would start at 0, 0 for a sine graph, but now we're starting at pi over 6 and then 0 since there was no vertical change. Pi over 6, 0. Let's fill in the x values first. They are going to be a little bit tricky. Get ready to add a bunch of fractions together. So we start at pi over 6. We're going to increase it by pi over 4 to figure out the next x coordinate. So I'm going to come over here and say pi over 6 plus pi over 4. The common denominator would be 12. This would be 2 pi plus 3 pi over 12, right? Because I would multiply this guy by 2 over 2 and this one by 3 over 3. And I end up with 5 pi over 12. Okay? To figure out the, oh, that looks gross. To figure out the next units, I'm going to take 5 pi over 12 and add the increment to it. So I'm going to add pi over 4 to it. 5 pi over 12 plus pi over 4. This would be, need to multiply by 3 over 3. I can see here that's going to be 8 pi over 12, which simplifies to 2 pi over 3. So this will be 2 pi over 3. I'm running out of space here, so I am going to erase these just so that, well, I can work at the bottom. Okay, the next increment, we're going to take 2 pi over 3. Ooh, I can't write right there. Let's try again. Let's go here. 2 pi over 3. And we're going to add the increment of pi over 4 to it. Common denominator is 12, so this one needs to get multiplied by 4 over 4. This one gets multiplied by 3 over 3. This is 8 pi plus 3 pi is 11 pi over 12. 11 pi over 12. And then our last unit is going to be 11 pi over 12 plus pi over 4. And I see I need to multiply this one by 3's. This would be 11 pi plus 3 pi, that's 14 pi over 12, which is 7 pi over 6. 7 pi over 6. Just to check, so we can't confirm based on the period because we did have that horizontal shift, but if we take the end point of the period and subtract it by the beginning point of the period, that should equal pi. So 7 pi over 6 minus pi over 6 should equal pi, which it does because it would be 6 pi over 6, so that's good. So I feel good about the x coordinates. Let's talk about the y coordinates. So the y coordinates, the good news is we just have to follow the amplitude. So this is a sine graph. It usually goes from 0 to the top, 0 to the bottom, 0. And that's exactly what it's going to do since a is positive. The top in this case is going to be a half. So it's going to go up to a half, back to 0, down to -1/2, back to 0. Now, the graph is going to be a little bit tricky. So help me out here. Bear with me. I'm going to do the best I can to explain how we're going to label the x-axis. So remember, the increments we used were pi over 4s, and the starting point is pi over 6. So I can't just start the way I normally start because I need the increments to be the same for each of these little tick marks here. So this has to be the same as this, which has to be the same increment as that. So what we have to figure out is, okay, well, pi over 4 is the increments we need for the graph, and pi over 6 is where we need to start. So what we're looking for is we're actually going to look for the common denominator of those, and that's the increment we want to use. 6 and 4 both go into 12, so we actually want to use increments of pi over 12s. That would put here pi over 12, 1 pi over 12. This would be, I'm just going to really exaggerate it and put it down here. This would be 2 pi over 12, which would be pi over 6. I'm going to skip this one just because these are going to get messy, but you're going to have to bear with me with this. This will be 3 pi over 12, which is pi over 4. This one will be 4 pi over 12, which is pi over 3. This one will be 5 pi over 12, and I think we actually want this one, so I'm actually going to write this one, 5 pi over 12. This one will be 6 pi over 12, which will be pi over 2. This one will be 7 pi over 12. This one will be 8 pi over 12, which will be 2 pi over 3. 9 pi over 12 would be 3 pi over 4. 10 pi over 12 we're writing as 5 pi over 6. 11 pi over 12 we want because it's part of our graph, 11 pi over 12. This would be pi right here. Then we need, are we there yet? Nope, we still need one more. We need this 7 pi over 6. Okay, so we're at 12 pi over 12. This is 13 pi over 12. Here's 14 pi over 12, which is 7 pi over 6. Yes, these do get complicated, but look, there's one period, and I think we're just going to focus on that one period. I don't want to have to repeat this going into the negatives, but we know what to do. Okay, so the middle line for this graph, since there was no vertical change, will be here. So every other point should hit that midline. This is a sine graph, so it should start on the midline, but we're starting at pi over 6. So pi over 6 was this one here, and it's pi over 6, 0. Now I'm only going up a half, so up here I'm going to call this 1, and down here I'm going to call this -1. That way this is my half, and this is my -1/2. The next one is 5 pi over 12, which is here, and we're going up to a half. Since a is positive, we go up first. At 2 pi over 3 here, we go back to 0. 11 pi over 12, we go down to -1/2. And at 7 pi over 6, we go back to 0. So one complete period would look like this. And we could repeat the process going into the negatives, but again, it will get pretty complicated. So I think we're just going to stick with one period for this example. In our final example, we are looking at every type of transformation humanly possible. Let's see what happens. So our amplitude is going to be -2, the absolute value of -2, which is 2. The negative indicates that the graph, normally it would go middle, up, middle, bottom, middle. This one's going to go middle, bottom, middle, top, middle. So it'll look like that instead because of the negative. The period, that's going to be 2 pi divided by b. This is going to be 2 pi divided by 3. This one is going to get messy. Okay, we also have these transformations. So this is a horizontal transformation, and it's taking the graph and it's shifting it to the left pi over 2 units. So left pi over 2 units. And this is moving the graph down 2 units. So this is a vertical shift, and it's moving it down 2 units. So that indicates that our midline will be at -2. So I might just draw that in. So we know every other point needs to hit that line. But we have to figure out what these points are. And again, we're only going to do one period due to the complication of this. Okay, let's figure this out. So first we want to know the increments for this. So we're going to take the period and we're going to divide it by 4. That's going to be 2 pi over 3 divided by 4. That's going to end up being pi over 6. All right, so we're adding pi over 6's a bunch of times. Normally this graph would start at 0, 0, but this one is going to the left, so it's actually going over -pi over 2 units. And instead of starting at 0, it's starting down at that midline -2, right? So sine always starts at the midline. Okay, let's figure out these x values. So the increments are pi over 6's, so we're going to keep adding pi over 6's until we get to the end. -pi over 2 plus pi over 6. We need a common denominator, so we're going to multiply by 3 over 3. This would be -3 pi plus 1 pi would be -2 pi over 6, which is -pi over 3. So next we're going to have -pi over 3. Okay, to figure out the next increment, we're going to take that one, -pi over 3, and we're going to add pi over 6 to it, plus pi over 6. We need a common denominator. I'm going to multiply by 2 over 2. -2 pi plus 1 pi would be -pi over 6. So this one's going to be -pi over 6. All right, for this one, we get a break here because it's -pi over 6 plus pi over 6. Anytime you add two opposites, the result is 0. Yay! And then 0 plus pi over 6 is pi over 6. So that ended very nicely for us. Whew, that was lucky. All right, now filling in the y's. So remember, y is starting in the middle at in this case, -2 is our middle. Because the y value is negative, so because of this negative here, it's a little confusing since there are two -2's. I apologize for that. This indicates that we're going down 2 units. So from the midline at -2, we're going down 2 units. That's going to put us at -4. We go back to the middle. We go up to the top, so we're going to take -2 and add 2, which is going to give us 0. And then we're going to go back to the midline at -2. Okay, so then from here, all right, we're ready to set up our increments, but remember these x increments, we need a bunch of different denominators. Look at the period 3, the denominator of 3. Look at the x starting value 2. We want to use units of pi over 6. So I'm going to use pi over 6. And then this would be 2 pi over 6, which would be pi over 3. 3 pi over 6 would be pi over 2. 4 pi over 6 is 2 pi over 3. I see I already don't need these, but I'll just continue just for fun, and I'm just going to reverse them on the negative side. This was 4 pi over 6, so this will be 5 pi over 6, and this will be pi. Okay? Oh, I could have spread these out. Oh well. I didn't, so now I can't. So this is negative pi over 6, negative pi over 3, negative pi over 2, negative 2 pi over 3. These are getting squished. Am I done yet? I think I'm done. I think I only need to start at negative pi over 2. Great. So I have my starting point, negative pi over 2. It's going to be negative pi over 2, negative 2. Then negative pi over 3 down to negative 4. That amplitude is telling us it's a distance of 2. And the negative a is indicating we're going down. Back to the middle. Up to our peak at 0. Back to the middle. And that's the end of the first period. This one I can graph a second period, especially since I squashed everything in there. Normally I would spread these out, and I probably should have, but I didn't, so oh well. So the second period would start here at pi over 6, negative 2. It's going to follow the same pattern. Go down 2, back to the middle, up 2, back to the middle, ending at 5 pi over 6. So this one would look like this. And that's how we graph transformations of sine and cosine graphs.